Welcome to Westel's Passive Components for Inquiring Minds. In this episode, we will discuss hybrid couplers and 50-ohm loads. What are hybrid couplers and 50-ohm loads, and what are their practical applications? A hybrid coupler is a 4-port device with 2 inputs and 2 outputs. When using a single input with both outputs, it acts similarly to a conventional equal power divider. The same applies to opposite traveling signals, where 2 inputs and 1 output work like a two-way combiner. Notice that in both examples, the unused port is terminated with a 50-ohm load. We will cover 50-ohm loads more later. Still, for now, it is important to understand that in the RF world, connectors should never be left unterminated, and a 50-ohm load is typically used to terminate unused connectors. So, what is the 4th port used for, and what are the advantages of a hybrid coupler over a conventional two-way equal power divider? When used as a combiner, both a traditional two-way power combiner and a hybrid coupler divide the input power in half at their output. The same is true for the second output of the hybrid coupler. However, if the second output is also used to drive antennas instead of being terminated with a 50-ohm load, nearly all of the input power is delivered to perform work with only a small insertion loss. Another advantage of the hybrid coupler in this scenario is its maximum power input power rating and its port isolation specification. From the power divider episode, we learned a reactive power divider should never be used in this scenario due to poor port isolation. This is not an issue with hybrid couplers. Also, from the power divider episode, we learned that the Wilkinson power divider, while having good port isolation, is not suitable for high-power applications. This specific hybrid coupler can handle 300 watts. When combining the outputs of 2 amplifiers, it is highly recommended to use a hybrid coupler or a crossband coupler. As with all passive components, they have lower and upper frequency limits. This specific model may be used with public safety UHF and the 700 and 800 MHz bands. It is not suitable for VHF or higher frequency cellular bands, but other models can be engineered to cover those bands. Hybrid couplers can be used in the test and measurement environment. For this application, it is essential to note that a hybrid coupler can be designed so that the outputs are either 90 degrees or 180 degrees apart. While necessary for test and measurement, it is not considered in typical public safety and cellular installations. Let's turn our attention to 50-ohm loads. In both public safety and cellular systems, every component is rated as a 50-ohm impedance. Connectors, coax cable, power dividers, directional couplers, tappers, and antennas are all rated at 50 ohms. When all the components of a system are matched to the same impedance, maximum power transfer occurs. It is therefore essential that there are no opens, as that will result in infinite ohms of impedance instead of the desired 50 ohms. 50-ohm loads, also known as dummy loads, are to be attached to any unused connectors within a distributed antenna system. They are also often used on the RF ports of a BDA when the BDA is not connected to an antenna system. Best practice is to keep the antennas disconnected during the initial power-up of a BDA just in case the BDA misbehaves and transmits unwanted noise. 50-ohm loads are rated by how much power they can handle. Be sure to use devices that can handle the transmitter's output power. Another use for 50-ohm loads is to troubleshoot voltage standing wave ratio or return loss issues. It is not uncommon for BDAs to measure the amount of reflected power they receive from the passive network. Passive networks reflect the transmitted power back to the amplifier if they have an impedance other than 50 ohms. If a BDA is reporting too much reflected power through its voltage standing wave ratio or return loss measurements, and test equipment to troubleshoot the issue is not available, a 50-ohm load can be used. Start by placing the load directly at the BDA's output. If the BDA is still reporting excessive reflections, it's bad. If the BDA now shows low reflections, the problem lies with the distributed antenna system. Reconnect the coax cable, then move the load to the opposite end of it. If the BDA reports excessive reflections, then the coax cable is bad. If the BDA reports low reflections, then the coax cable is good. Keep moving the 50-ohm load further into the system. When the load is connected to a cable or device that causes the reflections to go from good to bad, that cable or device is the issue. You should now know the functions of hybrid couplers and 50 ohm loads, as well as their applications.